Okay, next is self-inductance. Symbol is L. The self-inductance is defined as the ratio of the self-induced, or we call it as back EMF, to the rate of change of the current in the coil. So you can rewrite as L is equal to negative induced EMF over di per dt. Okay, so note here, when the current is increased, okay, note kat sini, when the current is increased, the change in current di is positive. So induced EMF adalah negative because to oppose the increasing in current. So kalau induced EMF kita positif, it is because kita oppose the decreasing in current. Okay, jadi kat sini nilai L ni tak boleh negatif. Okay, let's say kalau tiba-tiba you nak jawab L sama dengan negatif induced EMF over di per dt, memang you kena masuk negatif ni, tapi you kena tahu induce ni dia jadi maksud saya current dia ni perubahan daripada change dia macam mana, adakah changing dia positif atau change dia negatif. So baru you tahu EMF you tu positif atau negatif, sebab you nak jawab L ni nilainya sentiasa positif. Okay, so nanti kita tengok contoh tau. Okay, by comparing formula induced EMF by induced EMF formula Faraday's law dengan induced EMF by the self inductance, so kita combine, kita akan dapat relation L self inductance L is equal to NV over I. NV ni magnetic flux linkage, that's why dia tulis yang ni. Okay, sama je NV sama dengan V besar ni, flux linkage lah. Okay, kalau rasa takut nak guna yang ni, guna je yang ni. Okay, tak ada masalah pun. Okay, so it is scalar quantity and its unit is Henry. The value of the self-inductance depends on the size and shape of the coil, number of the turns, permeability of the medium in the coil. Mu lah, selalu mu kita standard lah. Okay, the circuit element which process mainly self-inductance we know as inductor. So maksudnya elemen yang kita guna dalam self-inductance adalah inductor. Kalau resistor. Okay, contohlah, it's used to store energy in the form of magnetic field. Kalau inductor, dia form dalam magnetic field, store energy. Kalau capacitor, dia store energy dalam electric field. Macam tu. Okay, this is symbol for inductor in electrical circuit. So inductor ni nanti you akan jumpa next chapter. Next chapter you akan belajar tiga electrical circuit: resistor, capacitor, inductor. So that's why you kena belajar inductor dulu. Okay, self-inductance in the coil and solenoid. Selalunya dua lah, coil dengan solenoid. So beza dia dekat sini formula lah. Kalau coil, you tahu B dia adalah apa kan? Dah belajar chapter 4. So substitute the value of B, so you dapat magnetic flux dia sama dengan nilai ni, and then self-inductance of the coil L sama dengan mu naught and power of 2A over 2R. Okay, untuk solenoid, for solenoid you know that the formula for B is equal to mu naught and I over L, and then we substitute in the formula of self-inductance, so you akan dapat L is equal to mu naught n square A over L. Bawah dia je beza. Kalau coil 2R, kalau solenoid over L. Okay, alright, jom kita tengok soalan. We have 300 turns of the solenoid is 0.5 cm long when the current in the solenoid is increased from 0 to 2 ampere. Increasing of current. Okay, 2 second. The magnitude of induced EMF is 0.015 volt. Calculate the inductance of the solenoid. So formula inductance of the solenoid, L is equal to negative induced EMF over di per dt. So nampak tak kat sini saya letak apa ni? Saya letak negatif. Kenapa negatif saya letak dekat situ? Because current dia ni daripada 0 kepada 2. Maksudnya dia berlaku peningkatan. So kalau kita tolak, dia adalah DL yang positif. Okay, tengok sini. Balik ayat. Okay, DL yang positif. Nampak tak sini ayat dia ni? Change in current is positive. Maksudnya final tolak initial dia positif. Okay, so induced EMF dia negatif. Sebab dia oppose the increasing in current. So, kamu kena letak negatif dekat sini supaya L kita dapat nilai positif. Faham? Ni yang saya bagi tahu tadi. Selalunya kalau pelajar tengok nampak nilai, you pastikan you letak ni betul lah. I initial tolak I final tau. I final tolak I initial. Okay, so dapat L ni negatif, mesti something wrong with this. Okay, so next, the cross-sectional area of the solenoid. So ambil formula solenoid lah. Mu naught N power of 2A over L. Okay, so L besar ni adalah induce self-induction. Self-induction, so masukkan nilai self-induction kita dapat di sini tadi. Okay, so dapatlah area 6.631 times 10 to the power of negative 4 meter square. And then the final magnetic flux linkage through the solenoid. Final. Jadi bila final, L sama dengan N flux over I. So N flux ni magnetic flux linkage. Gantilah magnetic flux linkage over I. So nak dapatkan magnetic flux linkage, L darab dengan I. So I ni kena guna I final lah, sebab dia nak magnetic flux linkage bagi final. So 0.030 Weber. Okay, hi. This is a self-induction experiment. The effect of the self-induction can be demonstrated by using this circuit. Okay, what you can see here, we have supply, battery, switch, 2 bulb A1 and A2, inductor, and the resistor are connected to A2, inductor is connected to bulb A1. Okay, so now, initially the variable resistor R is adjusted so that the two lamps have the same brightness in their respective circuit with steady current flowing. And now, when the switch S is closed, you can see that the lamp A2 is seen to become bright almost immediately. Isn't it? Okay. But what will happen to the bulb A2? When the switch S is closed, we can see the brightness is increased slowly to full brightness. Why this happen? Okay, this happened because the coil inside the inductor undergoes the self-induction and induced EMF in it. So the induced or back EMF oppose the growth of the current so that the glow in the lamp A1 increase slowly. So for the resistor, there has no back EMF, hence the lamp A2 glow fully brightness as soon as the switch S is closed. So here we can conclude that the back EMF is occur to oppose the growth of the current flow in the lamp.